All right, B given A. So first thing that has to happen is A. So I need to come up to A where you have 2, 4, and 6 here at part B. Within the 2, 4, or 6, event B says the outcome is less than 4. Okay, so within 2, 4, and 6, how many numbers are less than 4? And that's just the 2. So probability of B given A would be 1/3. Okay, A and B. So I'm going to take set A, which is 2, 4, 6, and set B, which is 1, 2, 3. And I'm going to find what is common since it's an AND probability. So between 2, 4, and 6 and 1, 2, and 3, the only number that is the same is a 2. So the probability of A and B would just be 1 out of 6. Notice that this is not a conditional probability anymore. So the number on bottom will be consistent with how many outcomes are within the sample space. A or B. Now this is putting everything together without any repeats. So I'm going to have 1, 2, 3, 4, and 6. So I'm putting set A and set B together. So the probability of A or B would be 5 out of 6 because I have 5 numbers in my set A or B out of 6 numbers possible within my sample space. Okay, A or B prime. So first we're going to find B prime. So that's everything that B is not, and B is a 1, 2, or 3. So B prime would be a 4, a 5, and a 6. So that means A or B prime would be 2, 4, 5, and 6. Remember, you put them together, just no repeats. Both B prime and the A both have a 4, so I'm just going to list that once. So the probability of A or B prime, well, I got 4 numbers here out of 6. Take a 2 out, so that'd be 2/3. Okay, the outcome is a prime number. Well, there's only one prime number within this sample space that is, or sorry, that's not just one. So let me back up. N is 2, 3, and 5. Those are the only prime numbers within this set. So the probability of N would be 3 out of 6, or half. Okay, event I, the outcome is 7. Okay, well this goes from 1 up to 6. So event I can't happen. So this is actually a null set. So you draw a circle with a line through it. And the probability of I would be 0. Because remember, the probability of 0 means that this is impossible to happen. So this is like saying, what's the probability of rolling a 7 on a 6-sided die? Well, it can't happen. It's impossible. So the probability of that event rolling a 7 on a 6-sided die has got to be 0. Okay. Another way you could see probabilities is within a table. So for here, we're going to look at M will be for male, F will be for female, R will be for right-handed people, and L will be for left-handed people. Okay, so the probability of male given this table right here. Well, first off, I have to count how many males are within this table. So we're going to look at this right here. So I need to take that 43 plus 9. It's going to give me 52. Okay, so there's 52 males out of, well, in order to find the total or how many people we're looking at, we'll take the 43 plus the 9 plus the 44 plus the 4, and that's going to give us 100 people. So this would be 52 out of 100 people. Okay, for females, we do the same thing. We're going to add up how many females we have, and it looks like that's going to be 48. So this would be 48 divided by 100. Okay, and then look at right-handed people. So that's going to be 87. Okay, so this is going to be 87 out of 100. And then same thing for left-handed people. We're going to add this up. So this would be 13 out of 100. Okay, so now we're looking for the probability of male and right-handed. So they're both at the same time. So male and right-handed. So that would be 43. So we've got 43 people out of 100 that are male and left-handed. Okay, well, male and right-handed. Female and left-handed. So female and left-handed right here. So probability that this one person is both female and left-handed will be 4 out of 100. So probability of male or female. Remember, we're going to combine together, no repeats. So we said that we had, looking at this one, we had a total of 52 guys and a total of 48 females. So what we're going to do here is we're going to take 52 plus 48 divided by 100, which that's going to give us 100 divided by 100, or 1, because that's all the people that we're actually looking at here. Okay, probability of male or right-handed. So I need to emphasize we're going to combine together, but no repeats. So we're going to look at how many guys do we have? We have 52. And then how many right-handed people we have? We have 87. But notice right here, I just did a double count. I counted these 43 people once when I counted the guys, and then I counted these 43 people again when I counted right-handed people. So what I need to do is I'm going to add the 52 plus the 87, but then I'm going to subtract the 43 once. So now it's not counted twice, it's only counted once. And then I'm going to divide by 100. It will give us 96 out of 100. And then you do the same thing for female or left-handed. So we'll count all the females, 48. All the left-handed people, 13. But notice that I counted this 4 twice. So I'll take the 48 plus the 13 minus the 4, and then divide by 100, which will give me 57 over 100. Okay, let's get down to this one. The probability of being right-handed given male. So we're going to look within this category first, because remember the second part is the one that you have to do first. So males, and then within that category, how many of them are right-handed? Well, that's going to be 43. So 43 out of how many? Well, 52 guys. So 43 out of 52. Okay, so probability of female given left-handed. The first thing that has got to happen is they have to be left-handed. Within that category, how many of them are female? Well, you've got 4 out of how many left-handed people? 13. Okay, then switch it around. Probability of being left-handed given female. So first thing we're going to look into the category of females. How many of them are left-handed? You've got 4 out of how many females? 48. There it is.